Now, this is a step that we did not do previously in Honors Chem, and what you'll find sometimes is there's more than one possible Lewis structure. So for instance, if I take CO2, there are two possible structures, because carbon is 4, oxygen is just 2, and there's 6 each. That's 12 plus 4 is 16. And if I arrange them, I can come up with two different structures. Okay? So the idea with formal charge is you want to look at the structures you come up with and compare them. So let's just compare them the way that the rules say we compare them, and then we'll talk about what the results mean. So I first start off by listing the valence electrons. Oxygen has 6 valence electrons. Normally, this is when it's not in a bond. Carbon has 4, oxygen has 6, right? Same for both. Okay? Now, if I look at electrons assigned to the atom, I've got to count any lone electrons that are on that atom alone, plus if they're in a bond, I take half of those two. So I've got 1 here and 1 here, that's 2, 4, and 6. So I also have 6 electrons assigned. Carbon, I have no lone electrons, but I have 1, 2, 3, 4. 1 each from these 4 bonds, that's 4. The oxygen, I have 2, 4, 5, 6. So if I look at the difference between the valence electrons for the atom by itself, and I subtract from that electrons assigned in this structure, I get formal charges of 0, 0, 0. Okay? As opposed to if I looked at this structure where I have 1 single bond and 1 triple, now I have this oxygen has 2, 4, 6, 7 electrons assigned, which gives it the difference between the 6 it normally has as an atom and the 7 assigned here. It gives me a -1. The carbon has a 1, 2, 3, 4 formal charge, which is okay, and the oxygen has 2, 3, 4, 5, which gives it a +1. Okay? So when we do that, the rule is if you have a structure where the formal charges are all 0, that's your preferred structure. Okay? And the second rule that we'll look at a little bit more in detail is if you end up with two, let's say you have 2 situations where they both come out with a charge, what you want to make sure is the most negative of these belongs to the most electronegative of the atoms. So we'll look at an example with that. Alright, so if we look at, here's the example. So if we were to do the formal charge, let's just do it for practice. 2, 4, 6 plus 1 is 7. You should do this by yourself first. So nitrogen, so I'm going to pause, okay, and you come back when you're done. Alright, welcome back. So nitrogen only has 5, carbon has 4, oxygen has 6. 5, 4, and 6, 5, 4, and 6. With this structure, with a single and a triple, oxygen has 2, 4, 6, 7, which gives it a -2. Carbon has 1, 2, 3, 4, which makes it okay. Oxygen has 2, 3, 4, 5, which gives it a +1. Now you want the charge on this whole thing to end up being the charge of this ion, which is -1. And this comes out to be -1. But let's take a look at this. 2, 4, 5, 6. This makes it a +1. I'm sorry, this makes it a -1. Carbon has 1, 2, 3, 4, which is 0. Oxygen has 2, 4, 5, 6, which is also 0. So this also comes out in total as a -1, matches here, just like this did, came out -1, and it matches. Now nitrogen here has 2, 3, 4, 5, okay, carbon has 1, 2, 3, 4, 0, 0, and oxygen here has 2, 4, 6, 7, which gives us a -1. Okay, so these all come out to be -1. So now we want to look at that the -1 belongs to the atom that's least electronegative. So if I look at my periodic table, oxygen is more electronegative than nitrogen, and carbon is less electronegative than nitrogen. So you want the most electronegative atom to have the negative charge, and in fact this would be the preferred structure. because you want the oxygen to have a -1. Okay, so that's how formal charge works. Okay, so you should be able to do a whole bunch of Lewis structures. If you need practice with that, I can give you some worksheets for those back from Chem 1.